Guys, let's have a little fun here. It's going to be a short video, although I do have an hour, 10-minute video I have to post. I've already made it, but I wanted to do this little excerpt from it. Sliding shear. Sliding shear. All these great, and I'm being facetious, these great structural engineers that state 11 pushed off number 12. Well, the image we're looking at, page 68 of the OSHA report, shows the condition of number 11 before failure, while someone obviously is standing on it. They could put a tape measure or a brick measuring tool down here to 7+ inches through this crack minimum. And you show slide vertical cracks, which are open and non-compressive. Open and non-compressive. So where is the force coming from that could do this? Well, it's already happened to do this. Number 12 is already taking a torque action, an elevation, a twisting action. And it's just sitting there. This is at the time of photograph when they decided they can post tension, where they could add with Denny Pate, and the rest of them agreed to adding post tensioning back into number 11, the member right here, to adding more compressive forces into a member that's already at this level of capacity. The engineers that attack me, and let's say engineer tip, let's call it that Earth guy, for example, who says he's a structural engineer from the down under, from Australia, and another one from wherever he's from. Seems to be two of them there, structural guys. What is his name? Green Llama. So that's another one. They don't even use their own real names. Their own identifying cells. They use weird things like that. So they can't identify themselves. They can't stand by it. I would welcome to do a video, and I would take down every last single one of my videos, delete them, every last one, if they could tell me the structural capacity of number 11 at this point. The structural capacity of number 11. If they could tell me the structural capacity of number 11 at this point. So the videos will stay, because no one in the world can tell me the structural capacity at this point of number 11, because they never did an evaluation of the structural capacity of number 11. They all assume that it's just in condition. It's just perfect. It's okay. Including everyone who believes number 11 pushed off 12 or pushing off 12. It's not pushed off 12 at this point, and yet you're looking at a member that's failed. Twisted, torqued up, everything else. These guys state that they're structural engineers. Look to your right here. See the whatever that is, the elastic ability of this coating. It looks like it's stretching. It shows again how high of a torque action this whole thing is taking. Number 11 is twisting. Let's have a little fun with the pushing off number 11 now. Let's use the OSHA report here. 11, that will just trigger me more and more. But let's use number 11, still pushing off. Look at that, really? We already talked about the elevation of this, that it's actually going higher in the air, not pushing down. You can see right here with the tape measure that that's about 3/4 inch gap. We talked about it's elevated, and you can use their own tape measures to see the elevations and our own markings. But I want to do this just a little bit differently this time, and reverse, and hustle it up, hustle it up. And it's getting ready to get paused video in just a moment. Okay, so rotate counterclockwise. So this is supposed to have pushed through, number 11 is supposed to have pushed through all this reinforcement and caused no deformation of such. No real deformation of such that what you would think. Number 11 pushing through there magically goes across this 12-inch hole, because it's 12 inches, an 8-inch pipe, but a 12-inch hole, pushing through the back end towards us. And yet there's nothing structurally below this besides some concrete. But yet, even though it's pushing towards us, it's able to create all this blowout down here and way over to here, in fact. How is that possible? It's pushing towards us. Well, because it's not possible. It's already failed. It's crumbling. It's deteriorated. And yet it has enough force to take out solid, this great concrete. No, these cracks have already been identified. Because number 12, the load of 12, when they detension the top part of B, bar B in this number 11, that allowed number 12 to take an action downwards. This is a shear downward action. This is looking at shearing of number 12, the dead loads coming down at a 45 this way and that direction. That direction. That's a perfect 45 pretty much going that direction and that direction from the loads of 12 and a downward force in this direction, which then would account for how it's able to break the backside, the underside of a pipe, because the forces will still be able to push this off down below. It accounts for the shape of this and a downward motion, the deflection of the reinforcement. If it was punch out towards us, this reinforcement would come towards us. But since it was downward, the reinforcement was able to take it, besides with this slight deflection here, and here's our downward motion here in this reinforcement. Downward, not towards me, downwards. It's just as simple as that. Now let me do this. Same thing here. We're going through here, and their capacity is going through, but yet none of this reinforcement is bent away from us. It appears to be bent in a 90 degrees still. It's just deteriorated. There's nothing there. There was nothing structurally sound. Well, there was some structural stability of it. Nothing worth anything, not to its capacity, not to its design capacity. And so they come across, here's D1. This is D1, and that's D1 left and right, however you want to look at it. D1, left and right. Pausing video. Looking at this image, again, they have it as sliding, pushing it off. So it pushes it off, it breaks the pipe, it then has a redirect and forces all this concrete from the bottom off. No, if it's sliding off, it's in that capacity. Number 11 is at that angle. It's pushing off 12. Why is there no rebar pushed away? Why is there no reinforcement pushed away? It already pushed it off. It already made the concrete weaker. Well, 11 doesn't have the capacity. So potential line of crack between compression and tension zones. So here's their basic neutral axis zone here, the shear. And it goes right up to D1 and up to D1 here. Here's the top view of how the OSHA report shows. The top view shows it doing that, pushing all of this off. Then we have assumed planes of punching shear. Again, going through there, same deal. Same deal, except for when we look at the real image. So we see that the real image is photographically wise. We see all this in place. But yet it has this missing. This is missing, and this is missing in here, all the way up to D1. As you look at the OSHA report, we see here that it's not missing. It's a straight path right through it. Shear coming down, this would have explained it. Explains why the rebar wasn't torn up. And torn up. I'm going to stick with torn up. Deflected as much as it should be. I like torn up. We look here, and you see that it's, again, this would be the way I describe it, but the way they describe it, it has to, this is where the pipes are. This D1 is, where are you hiding at, D1? D1's right about here. They have, and here's the width of it. It's just perfect. Here is the section between there. They have, so here's number 11, 12, right between these two pipes. Right between the two pipes. And on the other side of there, we have the back, the mostly of number 12. We then have a 45 coming out of a sort, coming this direction and that direction towards D1s. But it's already failed. We've seen photographs of that. So that's it. That was while the bridge was still in the air. We see these cracks. So don't think that was during the collapse. I don't want you to think that. So we can clearly see that it's beyond the pipes. There's a hole here. And we come down to the overlay again. Let's go to his overlay. It would be best if he'd overlaid his blue lines over top the real break. But when you have, no offense to the guy, when you have an agenda, you don't do that. You don't try to prove yourself beyond, like I'm doing, like a nut job. Prove yourself even attack mode, attack myself even to prove things right or wrong. He has it way back here. starting here and coming forward. In reality, we have the pipes are way up here approximately, right? So it starts here and comes forward. So how does he have his up here, shearing, creating this huge moment, shearing way back here? Here's the diaphragm out to here. The pipes are in the diaphragm way up to here and back to here. And none of this is fair. None of this fair game. It's just a clear hole through. So this, now we come to this. Now he's doing it again. The pipes are in place. He's on the opposite side of the pipes. If I were to superimpose the real break over top of this, it would look like it wouldn't look like this. I don't know if my software will work. Let me try some superimposing. If not, you guys take care. We'll find out which one it will be. Okay, so what I did was an overlay, and it's got some liberty in that one of the photographs is just this photograph. I did no rotation of it, no tilting of it, just grabbed it one-to-one. And his photograph, and what we have here is a top layer of just a printed copy of the real, of what they show is the path. OSHA shows the path. So the overlay, I'll fade it in, and then I'll fade it out. But let's fade it in right about there. You can see an overlay. I use there's D1s, and I use the part of the scale. So they kind of line up. The D1s do, center line of this structure, the failure. So I use that as a center line, and I overlay it over top of this best photograph I could find of the failed structure that we have. You can see it's kind of on an angle too, so there are some liberties. But with that said, if we just keep about an overlay there, and that's a center line, that's the path that it was supposed to have broken. This is not part of that path. This is not part of that path. That pipe is, and so is that pipe, and so is this section in here. And all the way up to D1, all of this section here is part of it. All of this section here is part of it. Yet it does not overlay. It does not overlay to work out that way. He just has it pushing off, and the failure, it's just, he did too much reaching. But he also has number 11 as being able to do it. Number 11 just doesn't have the capacity. It's just failed, as I talk about. Let's do that strong overlay like that. Remember, the pipes were broken after the fact, because we saw a photographs video before they cleaned this debris out, and you can see that these pipes are not broken. Let me pause the video and see if I can do something else for you. Further, I think noteworthy is he has it coming from this section here, where it was not pointed, if you will. It was 1'9", something like that, width-wise. So would that not be coming from the outside edges, since it's being pushed off? Would it not be from here, the 45, from here outwards, and from here outwards? Yet he has his 1'9". All the loads are concentrating in the center of this, doing this. So now let's do a little bit of scaling with that, and let's back it up to where it would then be encompassing. That would now put the points here and here, and using this 45. Now all of a sudden we've got the failure that has to be way out here and way out here to cause that issue, to have it, because it's pushing the entire thing. Which, well, correction, let me correct myself. It's got to be inside the pipeline. The pipes, inside the pipes. I had it outside the pipes. So maybe a little bit of rotation on that. I think I can rotate just a slight bit to count for this. Oops, too much. To try to put it back in square. So for our drawings, ooh, I'm at 180 now. Okay, so that would encompass all of this, past D1s now, into D2s, apparently. And that doesn't work out for me. That puts it at, well, maybe I got to push that back a little bit more to the edge line there. Yeah, back to the edge line, which now actually encompasses more. I've got to go the full width. We know the pipes are right outside the edge line, just by about 1 inch or 2 inch. So maybe I got to push it in a little bit. So now I'm running a square line in my mind, how that would go up, and a square there. So that would encompass a much larger area to have his theoretical sliding shear take place. That is based on this evaluation. Let's pause it. So in the OSHA report, this is the true path of the number 11, the deteriorated. I'm going to keep adding that, making that clear. Did you understand? Number 11 is not structurally sound. And so he has it budding from there and coming out. Well, it should be from here to here. Would you not state that? Why does he have it center lined, like the forces are center lined, they're all concentrated? You'd have to come back to here and here, and I'd put it way past D1. So I feed the 1'9" width. Now in this one, it appears to come this direction, and now we no longer have 45. See, that's a 90 degree right there. If we were to use these two path lines, they no longer meet at 90 degrees. So assume punch. So he's doing his own, first stating that it looks like it's a 45 degree, path. Forces love 45 degrees, right? So there's your 45, but then he shows this one, and now he changes it to assumed planes of punch shear to a different path now. And he's still crossing over. So if I grab this one now and I'll overlay it, he's still crossing over the pipes. It gets worse. It will get worse. I'm going to overlay this one over top of the same one for you guys. So now I added his other overlay. I butted it to, I guess I could do better than that. I'll butt it back a little. Nah, that's good enough. So I butt it there, and now we have this path. This path does not account for the rest of the cracking that goes way to the left and way to the right per this image on the background on this existing structure. It goes through the reinforcement, the bar here, the PVC comes around. The path does not account for this. It does not account for off to the right. This path is the made-up path, but it's not the true path of the real cracks, the back end cracks of this. I'm not sure if I can add the back end cracks, but I'm not sure if I want to bother with that. But you see, there's the overlay, and we have it not, and so now it's pushing entirely off the back there, and it's just going forward. He now has it he's just decided that the forces will change in this capacity, not discounting the reinforcement or counting the reinforcement or discounting it. It's just, here's the path. And it was because of D1s that caused this path to happen. Not detensioning, apparently not detensioning, and the movement of 12 is not even counted. And he also did not add or discount for the deteriorated number 11, which is just deteriorated, as I showed you in the beginning of the video. So I find this very important to note again, that this is the sliding off was able to, this is already fully cracked apparently all the way through. Sliding off was able to, pushing this off, this number 11, this totally deteriorated number 11, totally deteriorated, is able to also break off below this pipe. It's just amazing, this number 11, to be so structurally defective, yet have so much abilities left. Just ridiculous to be able to push off the base of that also. So this number 11, split like this, and open here, has the ability, and cracked all the way down to there, has the ability to push off number 12. This cracked up thing has the ability to do that. Just crazy. Just ridiculous to me. Here it is again. So this number 11, cracked up, twisted up, has the ability to push off the entire 900 tons or whatever you want to call it. I don't know, 50 tons, whatever you decide. It was down here. Priceless, just priceless. So enjoy this last part of the video. There's our failure, and they're saying that this has the ability to cause the failure. This cracked up, twisted up structure has that ability. This is able to do that. Just too amazing to state that. Plus with the gaps in it. Don't forget this has gaps in it. So this cracked up, gapped up member has the ability to, I'm trying to expand it one more time, that has a load, a force of pushing on, this gap has a force pushing on 12. How did they explain the rest of this member crossing over this air gap and then pushing on the side? I guess it's sort of like gravity. You just have to believe that the air pressure around it allows the force of the concrete to, since the air pressure is around it, to push across here at 14 point whatever. It's just crap. I'm just talking trash to you now. This did not push number 12 off the bridge. It's a gap. It can't push beyond the gap. All right. There's another gap present here also. The other gap is at the base of the structure, the base of this. And there are multiple gaps, but the other gap is over there to the left. Where are you? Gappy gap? Gap. We're going to terminate after I find this other gap for you. Oh, that didn't work. This crack over here. That shows that it's an air gap also, so it goes up. So this is not pushing 12. It doesn't. I'm done. Have a good day, everybody. Have a good day.